Let's now think about different ways to represent a mixed number. And let's say that our mixed number is 2 and 1/8. 2 and 1/8. Actually, let's make it a little bit more interesting. Let's make it 2 and 1/4. 2 and 1/4. So let's first think about the whole number part, the 2. Well, the 2 is going to be, the 2 is literally 2 holes. You could literally view that if you want. Right here, we've drawn each hole, we've cut it up into sections of 8. So it literally is 8/8. So let me just do it like this. So the 2 is this whole region right over here. That's 1. So this right over here is 1. And then this right over here is 2. 2 holes. So let me paint that in. So that is 2 holes. And then I have 1/4. So this last piece, this last hole is divided into 8 sections. So let me divide it into fourths first. So that's 1/4, 2/4, and 3/4. So we want one of those 4 to be filled in. One of those 4 in orange. So one of those 4 to be filled in. So just like that. You might notice that I filled in 2 of the 8s, and that's because 1/4 and 2/8 is the same thing. So there I've represented this mixed number, 2 and 1/4. Let's see how we can decompose this. So let's get our grids back. So how else could we do it? And I'm just going to throw a bunch of fractions up there and see what I get. See what I get. So the first thing I'm going to throw out is 1/2. So let's say that I want to throw out 1/2. So how would I represent 1/2 here? Well, if I take one of these holes and I put it into 2 sections right over here, a half would be this section right over there. So let me color that in. So we have a half. So I'm first going to add a half, which is the same thing as 4/8. And you see that I just filled in 4 out of the 8 sections, which is exactly half of this first hole. So we're making some progress. Now let's throw in, I don't know, let's throw in 3/8. So what would 3/8 look like? Well, 3/8, that's going to be, these are literally, each of these boxes are literally an eighth. And I could fill it in however I want, but let me just put, this is 1, 2, and 3. And then let's fill in plus, I don't know, plus another 8/8. 8/8. Now what's 8/8? Well, 8/8 is a whole. And I'll do that over here. I still haven't filled this one in yet, but I'll fill in this one right over here. So let's do that. So 8/8. So that's 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and 8/8. And it's a whole. So I have a whole hole here. So that's 8/8. I want to make this one a whole because I want to get to 2. So let me put in a 1/8 there. So plus 1/8. So plus 1/8. Well, that's going to be this one right over here. So that's my 1/8. And then let's add another, I don't know, let's add another 2/8. Plus another 2/8. Plus 2/8. Well, this is an eighths right over here, so 2/8 is going to be 2 of these. And notice, you see that the 2/8 is the same thing as 1/4. If you took each of these, if you took this 1/4 and split it into 2, so you have two times as many pieces, it becomes 2/8. And you see that if 1 times 2 is 2, 4 times 2 is 8. So that 1/4 is the same thing as 2/8. You see the 8/8 is the same thing as a whole. And you see you can make another whole out of 1/2 plus 3/8 plus 1/8. And they add up to a whole. And just to make sense of why that worked, this is 1/2 could be written, 1/2 is the same thing as 4/8, because you see that we filled in the 4/8. Then you have 3/8, and then you have 1/8, 1/8. And if you add all of these together, 4/8 plus 3/8 plus 1/8, you are going to get, in terms of eighths, 4/8 plus 3/8 plus 1/8 is going to be 8/8. 4 plus 3 plus 1 is 8. So you get 8/8, which is this entire whole. So hopefully that helps give you a visual understanding of what we're doing when we're adding and decomposing these fractions a little bit more.